welcome to the deep dive. You sent over some really interesting material, these handouts, detailing alarm settings on medical ventilators. And while it looks pretty technical at first glance, when you dig in, it's clear this is, well, fundamental to patient safety.
That's absolutely right. What we want to clarify today is why these alarms are just so critical. They're really a bedrock of safety in intensive care. Think of them as a constant vigilant monitor.
Exactly. So our mission for this deep dive is to really get to grips with these ventilator alarms. What are the different kinds? What actually triggers them?
Right.
Hopefully by the end, everyone listening will have a much better appreciation for this vital layer of support in respiratory care. Let's get started.
Okay, sounds good. Let's start with the most basic point. Why do we even need these alarms?
Right.
As the handouts make really clear, any failure in how a ventilator works can become, well, life-threatening very, very quickly. So these alarms are essentially the first line of defense, that warning system.
And it's not just about the machine breaking down, is it? The handouts use this term event. What exactly do they mean by event?
Good question. So an event is basically any condition or occurrence that needs the clinical team to be aware and, probably take action.
Okay.
And these events, they tend to fall into two main buckets. First, you've got technical events. These are things going wrong with the ventilator itself, unintended changes in its performance.
Okay. So like the power going out or maybe an issue with the air supply. Things originating with the machine.
Exactly that, like a warning light in your car. And the second category is patient events. These are changes in the patient's own medical status that the ventilator can actually pick up on.
Such as?
Like if the patient's breathing pattern suddenly changes, the alarms can flag that early on, so it's watching both the machine and the patient.
Okay, so that's the why. We understand the fundamental need. Now let's get into the what. The info you sent categorizes alarms into three main types.
That's right. The three big categories are input alarms, control circuit alarms, and output alarms. Each one monitors a different piece of the puzzle.
Input, control, output. Got it. Let's start with input alarms. The notes mention power. What kind of power issues trigger these?
Okay, so input power alarms are focused on what the ventilator needs to run electricity and gas. First, there's the loss of electrical power alarm. Pretty straightforward. If it gets unplugged or the mains power fails, it sounds.
Makes sense.
And importantly, many ventilators have battery backups. So there's usually a separate alarm, a low battery warning, kind of like on your phone.
Right. You need to know if the backup itself is failing. What about loss of pneumatic power? What's pneumatic power here?
Pneumatic power just means compressed gas. So for ventilators that use them, typically oxygen and air, this alarm goes off if the supply of either gas gets cut off or drops too low.
Like an empty oxygen tank, or maybe a problem with the hospital's main gas lines.
Precisely. Could be either of those.
Okay, so input alarms are basically watching the external lifelines for the ventilator. Now, control circuit alarms, that sounds more internal, like the machine's brain.
That's a good way to put it, yeah. Control circuit alarms detect problems within the ventilator's own operating system. The handouts highlight two main things here. One is if someone tries to set incompatible parameters.
What does that mean, incompatible?
Like telling the machine to do something logically impossible or outside its design limits, maybe setting a breath volume way too large for it to deliver.
Okay. Like user error, almost?
Sort of, or just conflicting settings. The other trigger is a failure during the ventilator's self-test. Most modern ones run checks on themselves, diagnostics. If something fails that check, an alarm alerts the team.
Like your computer flagging a system issue.
Exactly. It's a self-check mechanism.
It's reassuring. Okay, finally, the big one maybe. Output alarms. These seem directly tied to what the ventilator is actually doing for the patient, right? The breath itself.
Precisely. Output alarms are triggered when something's not right with what the ventilator is delivering or sensing back from the patient. And there are quite a few important ones here. We can start with volume. There's the low exhaled volume alarm.
Okay.
Which actually has two parts. There's the low exhaled tidal volume alarm, or Villenite tidal volume is just the size of one breath.
Right.
This alarm is usually set maybe 100 milliliters below the patient's normal exhaled breath size. It's really key for catching leaks in the breathing circuit, or even if the tube gets disconnected entirely.
Because if there's a leak, less air comes back to the machine to be measured. Makes perfect sense.
Exactly. If the returning volume drops off suddenly, it's a strong sign something's wrong with the connection.
And you said there's a second part, a low exhaled minute volume alarm. How's that different?
Right. The minute volume alarm looks at the total air exhaled over a full minute. It's usually set, say, 3 to 5 liters lower than the patient's typical minute volume.
Okay, so a longer time frame.
Yeah. And while it also flags leaks and disconnects, it can pick up more subtle changes too, like if the patient starts taking shallower breaths, lower tidal volume, or if their breathing rate slows down.
So minute volume gives a broader picture over time, while tidal volume might catch a sudden disconnect faster. Got it. What about the flip side? Too much air. There's a high exhaled minute volume alarm.
Yes, exactly. That one's set about 3 to 5 liters higher than the patient's usual minute volume. It goes off if the total air exhaled per minute increases significantly.
And why would that happen?
Could be the patient's taking bigger breaths, so higher tidal volume, or they're just breathing faster, increased respiratory rate. Or both.
Okay, so volume alarms keep track of how much air. Let's move to pressure. There's a low inspiratory pressure alarm.
The low inspiratory pressure alarm. This is typically set about 10 to 15 centimeters of water pressure, that's CmH2O, below the usual peak pressure reach when the ventilator pushes air in. That peak is called PIP, peak inspiratory pressure.
Okay, 10 to 15 below PIP.
Right. And if the pressure during inhalation drops below that setting, it usually points to the same kind of problems as the low volume alarm, a leak somewhere, or a disconnection, not enough resistance.
Okay, and then the high inspiratory pressure alarm. The handout really emphasizes this one. Bold text, exclamation points. Sounds serious.
You're right to pick up on that. It is very critical. It's at 10 to 15 centimeter H2O above the patient's usual peak pressure. And here's the crucial part. When this alarm triggers, the ventilator immediately stops pushing air in and lets the patient exhale.
Wow, it stops the breath mid-delivery.
Instantly. This rapid stop is vital. It's to prevent something called barotrauma, basically, lung injury from too much pressure. Think of overinflating a balloon until it pops. We absolutely want to avoid that.
Okay, that makes total sense why it's so critical. What kind of things cause that pressure to spike so high? The handout lists quite a few.
Yeah, it does. It could be several things. Maybe a simple kink in the ventilator tubing or water collecting in the tube blocking the flow. Or it could be something with the patient. They might be biting down on their breathing tube, or have a buildup of secretions in their airway. Or more serious things like bronchospasm, where the airways suddenly narrow, or even a tension pneumothorax, which is dangerous buildup of air in the chest. Or maybe their lungs have just become stiffer, less compliant, needing more pressure.
So a whole range of possibilities. Some simple, some very serious.
Exactly. And the handout rightly stresses, when that high pressure alarm goes off, the patient needs checking immediately to figure out the cause and fix it. You can't ignore that one.
Absolutely. Okay, moving down the list. High respiratory rate alarm.
Right. This one's usually set about 10 to 15 breaths per minute over whatever the patient's observed breathing rate is.
And what does it tell you?
Well, it could mean the patient is starting to breathe much faster on their own, becoming tachypneic is the term. Maybe they're in distress or getting anxious. Or sometimes it could just be that someone accidentally turned up the machine's set breathing rate.
So could be the patient, could be the machine setting. Got it. What about oxygen levels? FiO2 alarms, right? Fraction of inspired oxygen.
Correct. High and low FiO2 alarms. These monitor the actual concentration of oxygen the ventilator is delivering. The high is usually set 5 to 10% above the target FiO2, and the low is 5 to 10% below.
Seems straightforward, just making sure the patient gets the right oxygen mix.
Pretty much. It's crucial for accuracy, as too much or too little oxygen over time can cause problems.
Okay. Next is the low PPAP alarm. Now, PEEP and CPAP. Those are about keeping the airways open at the end of the breath, aren't they?
Exactly right. PEEP is positive end expiratory pressure. CPAP is continuous positive airway pressure. Both apply a bit of pressure constantly to stop the tiny air sacs in the lungs alveoli from collapsing when the patient breathes out. Helps with oxygen getting into the blood.
So what does the low alarm mean?
The low PPAP alarm is usually set, say, 3 to 5 centimeters HGO below the intended PEEP level. If the pressure drops below that...
Thanks again.
Leaks or disconnects are the most common culprits, yes. Or it could even be a failure in the PEEP valve itself inside the ventilator. If you lose that PEEP, you lose the therapeutic benefit and the patient's oxygen levels might drop.
Okay, that makes sense. And the last one on the list, the apnea alarm. Apnea means stopping breathing, right?
Yes. So the apnea alarm has a time delay built in, usually around 15 or 20 seconds.
Okay.
If the ventilator doesn't detect any breath from the patient, either spontaneous or triggered within that set time period, the apnea alarm sounds. It's a vital backup.
So if the patient just stops breathing effort for, say, 20 seconds.
The alarm goes off, and typically the ventilator will then automatically switch to a backup mode and start delivering mandatory breaths to ensure the patient keeps getting ventilated.
Wow. Okay, let's just take a breath ourselves there. That's quite a list of alarms,
Right.
but it's also incredibly clear how each one targets a specific potential problem.
It really is. And what's also quite clever, I think, is how they often work together. A single problem, like a major leak, might trigger the low tidal volume alarm and the low inspiratory pressure alarm and the low PEEP alarm, maybe all at once.
So you get multiple alerts pointing towards the same kind of issue, a layered approach.
Exactly. It provides confirmation and a more complete picture for the clinician trying to troubleshoot quickly.
So summing up then, these ventilator alarms, they're not just annoying beeps. They really are this complex, multi-layered safety net.
That's a perfect way to put it.
Actively monitoring everything, from the power cords and gas hoses right through to the pressure and volume of every single breath and the patient's own breathing patterns, all designed to alert staff to a huge range of issues.
From simple things like a kinked tube to, critical changes in the patient's condition.
Yeah.
And the real aha moment, I suppose, is seeing how these different alarms, input, control, output, all interconnect. They provide this constant, comprehensive view of both the machine and the patient. It allows the teams to jump in fast when needed.
It definitely makes you think. Considering how complex and absolutely vital these alarms are, it makes you wonder what other medical devices, things we might see as routine, have similar hidden depths of safety features we just take for granted.
That's a really interesting thought. There's often a lot more going on under the hood than we realize.
Well, this has been incredibly illuminating. Thank you so much for walking us through all the details from those handouts on ventilator alarms.
My pleasure. Glad we could dive into it.